Dear students, today we will discuss about transportation problem. In transportation problem, initial basic feasible solution can be calculated using different methods like north-west corner method, least cost method, and Hogel's approximation method. Out of these three methods, we will discuss least cost method in today's discussion. So before solving examples on least cost method, we should know what is the basic objective of transportation model. The basic objective of transportation model is to identify optimum transportation schedule, keeping in mind that the total cost of transportation will be minimum by how you have to schedule your supply and demand in such a way that whole demand will be fulfilled and whole supply will be complete, and the total transportation cost will be minimum. To find out that, we are using transportation problems. So before solving transportation problem, we should discuss some basic terminologies which are used in transportation problem. The first is the feasible solution. Feasible solution is nothing but any non-negative value of atom which satisfies the constraint of supply and demand. Means to fulfill the demand and supply, we have to distribute supply quantity to different distribution channels, or you can say different distributors, in such a way that the total supply will be finished and total demand will be fulfilled. So that non-negative values are called as feasible solution. Then what is optimal solution? From that set of feasible solution, any possible values that minimizes the total transportation cost, then that solution is called as, that feasible solution is called as optimal solution. Optimal solution is a feasible solution which minimizes the total transportation cost. There are two types of transportation problem, balanced and unbalanced. In transportation problem, we are dealing with demand and supply. If for a given problem, demand and supply are same, then we can see the problem is balanced problem. And if the demand or supply are not same, either supply is less or demand is less, then that problem is called as unbalanced transportation problem. Then last one is a degenerate basic feasible solution. Degenerate means what? For a particular case, there are 4 different suppliers and 3 distributors. So total members are 4 plus 3, 7. So 7 minus 1 is nothing but m plus n minus 1 value. So when you distribute the total supply and total demand, then you have to identify how many allocations we have done. So the number of allocations is equal to m plus n minus 1, then we can say the degeneracy is achieved. And if the number of allocations are not equal to m plus n minus 1, we can say the degeneracy is not achieved. We'll see this in while solving the example. Here the simple example is given to test whether the problem is balanced or unbalanced problem. So the given problem is unbalanced because we have to check the total demand and total supply. So total demand is nothing but here the total demand value is 500 units and supply is 450 units. So here supply is, here we can say demand is more than supply. So to make this balance, what you have to do? We have to add one dummy supply. You have to add one dummy supplier. So from this 19, 30, 50, what is this? These are nothing but the transportation cost. These are nothing but transportation cost which is required to transfer a single unit of atom from this source to this destination. So all these values are called as cost matrix or transportation matrix. These values are called as transportation matrix or cost matrix. So here I have added one extra source which is having 0 transportation cost but having capacity to produce 50 units. Now the problem is balance problem. Likewise in this case, the demand is 400 and supply is 450. So in this case, the demand is less than supply. So to make this problem balance, I have to add one demand, one distributor we can say, which is having 0 transportation cost but having demand of 100 atoms. So this should be 50, this should be 50, this should be 50, and this should be also 50. Typing mistake, 50. Okay, so demand and supply, now we have made balance. To solve the initial basic feasible solution, three methods were used as we have discussed: northwest corner method, least cost method, and Google's approximation method. So in least cost, now today we will see the least cost method to find initial basic feasible solution of transportation problem. So we'll see what is the procedure, what are the algorithm, what are the steps to solve the transportation problem using least cost method. So what is the first step? Select the cell having minimum, or we can say lowest unit cost in the entire table. You have to scan all cost values, and from that allocate the minimum. You have to identify the minimum value and allocate minimum supply or demand values in that cell. From the cost values, you have to identify minimum cost, and from that cost cell, you have to check demand and supply. Which value is minimum? That value you have to assign for that particular cell. Then eliminate the row or column in which supply or demand is exhausted. Means when you allocate the value of demand or supply, you have to subtract that value from demand and supply. So which value becomes zero, that row or that column you have to remove, you have to ignore. If both supply and demand values are same, either the row or column can be eliminated. You are having chance to if both are the demand and supply values are vanished, you have to remove both row and column also. In case the smallest unit is at more than one place, this is very important. If the smallest unit cost is more than two places, then what you have to do? Then you have to select the cell where maximum allocation can be done. For first cell, you have to check what is demand, what is supply. For second value, which we have to check demand and supply. From that value, demand and supply, which maximum value you can allocate, that you have to select. We'll see with the example also. And last, repeat the process with the next lowest unit cost and continue until all entire supply and demand will be satisfied or finished. We'll see with the example. Solve the transportation table to find initial basic feasible solution using least cost method. D1, D2, D3, D4, these are the distributors which are having demands of 5, 8, 7 and 40 units. S1, S2, S3 are the suppliers which are having capacity to supply 7, 9 and 80 units. Now they have asked you to identify minimum transportation cost so that the demand and supply will be fulfilled. First you have to check whether the problem is balanced or not. How to check? For that purpose you have to check what is total demand and what is total supply. Here demand is equal to 34 units and supply is equal to 34 units. So we can say that the given problem is balanced transportation problem. Then to solve this problem using least cost method, you have to check among this total cost, which is the minimum cost. So in this case, the 8 is the minimum cost. 8 is the minimum cost. So we have to select this 8 as a starting cell, or you can say entering cell. Okay, from here we have to start the allocations. So when you select this 8 as minimum cost, you have to check what is the demand value and what is supply value. Demand is 8, supply is 18. So out of this, which is minimum? 8. So we have to give 8 here allocations and subtract 8 from demand and supply. So demand becomes 0, supply becomes 10. So value of demand is exhausted. So I have to remove this column. So I have removed this column. Then next, what you have to do? From the remaining columns, remaining cells, we have to identify which is the minimum value. So in this case, the minimum value is 10. So I have selected this 10 column. Then we have to check supply and demand values. So supply value was 7, demand value is 14. So minimum is 7, so I have to allocate 7 here. Then subtract 7 from this supply, we get 0. Subtract 7 from this demand, we get 7. Getting? So the supply is exhausted, so we have to remove this particular row. So I have removed this row because the supply value of supply is 0. Now we have to check which is minimum value from remaining unallocated cost. Remaining unallocated cost. So from this, we can see the minimum cost is 20. So when you reach at this 20, we have to check the supply quantity, supply value and demand value. Demand is 7, supply is 10. Which is minimum? 7 is minimum. So we have to allocate 7 here. So 7 minus 7, 0. 7 minus 10, 3. Now this is 0, so we have to remove this particular column. Then from the remaining values, we have to check which is minimum. So now see, in this case, minimum value is 40. So 40 is here also and 40 is here also. 40 is here also and 40 is here also. So which value you have to select? So rule is that, suppose I am selecting this 40 as a minimum value. Then what you have to check? We have to check corresponding supply and demand. Here demand is 5 and supply is 3. So maximum how much allocation you can do? 3. But if you select this 40, then what is demand? 7. What is supply? 9. So which is minimum? 7. So here we are allocating 3 units. Here we are allocating 7 units. So rule says that select the cell which requires more allocation. So here is a more allocation, 7 units you are requiring. So we have to select this cell. So here I have selected 7 units as a demand, and subtract the 7 from this demand, you get 0. Subtract this value from cost or from supply, you get 2. Now this value is 0, so we have to remove this particular column. Then which is next minimum value? Next minimum value is 40. So we have to check the demand and supply. So demand is 5 and supply is 3. So minimum value is 3, so we have to allocate 3 here. You have to subtract 3 from 5, we get 2. We have to subtract 3 from 3, we get 0. So the supply value is 0, so we have to remove this particular row. Then we have to check which is the remaining value. This value is remain. So we have to allocate the remaining value to this cell. So here remaining value is demand is 2, supply is also 2. So I have to allocate 2 here and subtract this 2 from demand and supply. You get 0, 0. Now see, all cells are allocated, all demand value is 0, all supply value is 0. Means we have solved the example properly. Then how to calculate initial cost or initial basic feasible solution cost? For that purpose, you have to check m plus n is equal to 6. Here m plus n is nothing but, m is nothing but number of distributors, n is nothing but number of sources or supplies. So 1, 2, 3, 4. 4 is nothing but demand, we can say distributors. S1, S2, S3, these are 3 suppliers. The 4 plus 3 minus 1 is equal to 6, which is equal to number of allocations. So see how many allocations we have done? 1, 2, 3, 4, 5, 6. Means number of allocations is equal to m plus n minus 1. So now hence we can say that the degeneracy is achieved. Hence we can say that the degeneracy is achieved for initial basic feasible solution. Now total cost, total optimum transportation cost is equal to, just you have to do the multiplication of cost multiplied by allocated units. Cost multiplied by allocated units, and you have to do the addition. 2 into 70 plus 3 into 40 plus 8 into 8 plus 7 into 40 plus 7 into 10 plus 7 into 20. If you solve this example, you will get total transportation cost, that is rupees 840. So in this fashion, you can solve any transportation problem using least cost method. You can easily identify initial basic feasible solution. One note I have to bring to your notice that the total transportation cost you are obtaining using northwest corner method and least cost method, the cost of transportation is minimum as compared to least cost method, as compared to northwest corner method in least cost method. Total transportation cost is more in case of northwest corner method, and it is reduced in case of least cost method. So if you have any doubts regarding how to solve least cost method example, you can call me on my mobile number. My mobile number is 98500 and my name is Dr. B.J. Mohiti. And thank you for watching. If you have any doubts, you can call me. Thank you.